let's just say, listen. I'm for you, not against you. Not as perfectly as the Lord is. But I'm going to try and show you today what I want you to have for tomorrow. Why? Corey, I'm sorry. I've been on my calendar for a couple of weeks. I've been announcing that all these band people, you're trying to hang them in. But the nice thing is, a lot of band people have been coming in and working and asking questions and getting notes, etc. So those of you that haven't, maybe you haven't had time, but everything has been online. That's why I work super hard every day. Tons of minutes of every day trying to grapple with my computer and the internet to get videos and notes loaded online. Okay, here we go. On the back board, I have the quiz tomorrow being on 3-1, 2-3, 3-4, and 3-5. All of 3-5? No, not really, not to be honest. Not all of 3-5. Homework section 3-4 was technically due for today, but I realized there might be a few types of problems that you might have got a little stuck on. We have a few more examples from 3-4 to do today, and we're going to start section 3-5. Not entirely finish it, but start it. The quiz tomorrow is basically, I'll probably have another quiz next week, to be honest. The quiz tomorrow is basically just to see, can you take a function, and can you test that function for increasing, decreasing, concave up, concave down, relative extrema, and points of inflection. That's what the quiz tomorrow is on. Literally, that's it. Now, to do that, do you need to know how to do pitchfork critical numbers of the first derivative? Yes. Do you need to know how to do pitchfork pips of the second derivative? Yes. You need to know how to do all of that. However, rolls is not tomorrow, mean value is not tomorrow, and technically 3-5 is not tomorrow, so I should probably change that to be just 3-4. Okay? I'm going to go ahead and go back and change that on the back board. But you guys spent the beginning of class just getting down to these last two little bits of 3-4, especially those of you who were gone yesterday. And we're going to use them now and do an example all together now that I have everybody back. My band people back, my poll worker people back. And once again, we taped yesterday. And I think I taped period 6 because they got further, because let's just say your class was a little dead without you, my people who were gone. Here we go. Yesterday we did this example. Here we go. The very last thing in section 3.4, the very last forever card technically of this chapter 3a was how to find relative extrema using the second derivative. Okay? Did we already talk about how to find relative extrema using the first derivative? Yes. In order to find relative extrema using the first derivative, can anyone help me out really quickly? What homework number is 3.4? I erased it and forgot it. 25? 20? Okay. Thank you. All right. So, second derivative test. Here's how it works. Yeah, let's go with that. Second derivative test. Here's how it works. You guys have the steps right in front of you, so you wrote it down first thing this morning, right? Step number 1. It says do the exact same steps as the increasing, decreasing sign chart. Long story short, number 1, as we've been doing for section 3 and 3-4. What are we supposed to look for? Discontinuities. Okay. Oh, no, there's trig. Trig has discontinuities. Not these ones. Okay, come on guys, I need you to focus in because every example is important, especially with the quiz. Discontinuity, sine and cosine. Any problems? No. So therefore, discontinuity, none. However, we do need to remember our domain is what they told us it would be between 0 and 2 pi. Okay. Number 2. I know this is the second derivative test, but what do the steps tell us to do? Are we going to pips, or are we doing critical numbers? Which pitchfork are we doing? Because if you look at the step, it says discontinuity and who do we look at for critical numbers? First derivative. If you need to go back to the test you were writing at the beginning of class before we started, relative extrema still only occur at critical numbers. So, relative extrema, you always do the first derivative pitchfork. So first derivative, f prime. Derivative of 2 sine x is who? 2 cosine of x. And derivative of cosine of x? Ooh, that's cosine of u, isn't it? So what's the derivative of cosine of u? Yeah, negative sine of u times u prime, which would be the same thing as minus 2 sine of 2x. Just taking derivatives. All right, we have to set this puppy equal to 0. Pitchfork? No, there's no bottom, so just the top. Just the top equal to 0 to find our critical numbers. Now, there's a little bit of a struggle. How do you set this equal to 0? Wait. From pre-cal, isn't there a double angle of sine formula? Yeah. This is forever card number 1. At least part of it. The double angle of sine formula is 2 sine cosine. Why is that a good thing? Well, it's not good if we just have subtraction equal to 0. I don't know how to solve that. But if we have common factors and we can do something like pull out cosine. If I have factors equal to 0, guys, how do we solve that with, I don't know, algebra? Set each one equal to 0. So we made the substitution with the pre-cal formula to be able to factor. Then we can set each one equal to 0. 2 cosine equals 0. 1 minus 2 sine equals 0. When does cosine equal 0 between 0 and 2 pi? Unit circle. X equals pi over 2 and 3 pi over 2. When does, we have to solve. When does sine equal 1/2 in one rotation of the unit circle? Let's see, sine is positive in the first quadrant, second quadrant, because sine goes up instead of going down. At pi over 6 and 5 pi over 6. 1 pi over 6, and then take away 1 pi over 6. Pause. In the steps for using the second derivative test for relative extremity. Check for discontinuities. We did, there weren't any. Find the critical numbers. First derivative equal to 0. Or if it's a fraction, top and bottom equal to 0, pitchfork. We found the critical numbers. What do our steps say to do next? Plug into who? Okay. And test the sign of the second derivative of the concavity. And use this little test to make conclusions as to whether it's a min or a max. And remember, the second derivative test only works if there is concavity, which we'll know because the second derivative will equal a number. Okay, so to do that, we need to find the second derivative. So step number 3, not a sign chart. That's the first derivative test. But just find f double prime. Just find f double prime. Now, kiddos, I could take f double prime of this one, but I don't want to. There's a product rule. Ew, gross. I'm going to take the second derivative of this one. I probably shouldn't circle the 0. That's the derivative. That's going to be easier, and I'm going to get the derivative of cosine is negative sine. The derivative of sine is positive cosine, but there's a negative. There's going to be another u prime. So it's going to be negative 4 cosine of 2x. Double check me if you want. And do the derivative of sine is negative cosine. There will u prime in it. But how do we figure out whether these critical numbers right here are relative mins or relative maxes? Plug in. Nope, not even intervals. Literally plug in. We're going to plug in. I'm going to start at pi over 6. Then I'm going to go to, I'm just going in order of the unit circle. Pi over 2 would be next. Then I have 5 pi over 6. Then I have, this is the difference. I'm not doing a sign chart. All I want to know at each of these points is what is the concavity of f. And I can know that by plugging in and figuring out the sine of f double prime. Now, don't do this at home. You're going to have to actually think it through. But let me help really quickly. We know the unit circle, right, cool kids? In the unit circle, don't we know the quadrants of all students take calculus? Okay. So, if I'm just caring about signs, if I plug in pi over 6, what quadrant is that? Okay, so it's a positive number, right? Positive, positive, all are positive. So, pi over 6, sine is a positive times a negative. Negative. And then cosine of, well, 2 times pi over 6 is pi over 3, still the first quadrant, still a positive. What's a negative plus a negative?
Negative.
More negative. Make a conclusion about that in just a second. Pi over 2. Oh, wait a minute. Isn't that like a special one? Yep. Isn't that where cosine is 0 and sine is 1? Cosine, well, we'll get back to him. Sine is 1. Okay, so that would be negative 2. Maybe this is a little bit rougher. Maybe we'll write him. Sine is 1. That'd be negative 2. Minus 4. Okay, hold on. Cosine of 2x. Cosine of, oh, that'd be pi, right? 2 times pi over 2 is pi. Cosine of pi is going to be negative 1. Negative 1 times negative 4 is plus 4. Oh, hey, that's 2. I don't care about the 2. I care about this is a positive. Okay, I have a negative and I have a positive. 5 pi over 6, long story short, second quadrant. Sine is going to be a positive again, and more specifically a positive 1/2. Negative 2 times positive 1/2 is a negative 1. Minus 4 times cosine 2 times 5 pi over 6 is 10 pi over 6. 5 pi over 3, that puts it over here. Cosine is going to be negative root 3 over 2. Oh, no. I did the wrong one, didn't I? 5 pi over 3, it's going to be 1/2. There we go. What's a negative plus a negative? More negative. And then 3 pi over 2, that's my point. 0, negative 1. My sign is going to be negative 1 times negative 2 is a positive 2 minus 4 times cosine of the double angle. That'll be cosine of 3 pi. That'll be negative 1 again. That's going to be a positive. Okay. Long story short, we figured out our signs. Now, what do we know from that?
How to mean that?
Exactly. Because this tells me if the second derivative is negative, what is f at pi over 6? Concave, if the second derivative is negative, f is concave down, right? So, if there has to be a relative extrema, well, he must be a max. If it's concave down and it's a relative extrema, concave down only has a max. So I can label this one as a relative max, not the max, a max. This one, if the second derivative is positive, what's f? Concave up. And if it has to have a relative extrema, what's it going to be? Min. Think about the mixture. If f double prime is a negative, I don't care about the number, it's negative. What's f? Concave down. If it has to have a relative extrema, what's it going to have? A max. And a positive second derivative, it means f is going to be, once again, concave up. If it has to have a relative extrema, negative. So therefore, a relative maximum at, and relative minimums at. Relative maximums will be at x equals pi over 6 and 5 pi over 6. If I needed the point, I would go plug in and get y, but then let's do short on everything. And relative min is going to be at pi over 2 and 3 pi over 2. What's the difference in finding relative extrema with the second derivative than anything else we've been doing with increasing, decreasing, concave up, concave down, and relative extrema with the first derivative? There is no sign chart.
Yeah.
But signs are still important. The signs point us to concavities, and the concavity points us to what is going on at each of those different critical numbers. So, what's that second derivative test again? For relative extrema? At critical numbers. At critical numbers. If the second derivative is positive, concave up, ooh, it's a min. At a critical number, if the second derivative is negative, concave down, ooh, it's a max. And if the second derivative is 0, the test fails. You better go do an increasing, decreasing sign chart and figure it out that way. So, kiddos. Ooh, it's a nice derivative. Yay, it's a polynomial. Let's do a quick compare and contrast. Let's do relative extrema one way, and then let's do it the other way. Let's do relative extrema one way, and then the other way. We're going to do a little compare and contrast. You ready?
Yeah.
I don't want that. Why didn't you change? Bless you. There we go. All right. If we're doing relative extrema using the first derivative test, this is like back where we were in section 3.3. First derivative test. Our point is relative extrema. Okay, what's the first thing we would do? This is a good review of section 3.3. Yeah, figure out the domain. That's a polynomial. What's going on?
Infinite.
All real numbers. Okay, number 2, what will we do? First derivative
First
test.
derivative.
Find the,
First
make sure we're not on
derivative.
our phones. I don't want to take them. I've heard the office holds on to them. Not cool. Okay, first derivative. Who is he?
8 minus 3. X.
6x. Woo, that was close. After we find the first derivative, we should pitchfork. I'm doing it over here because I didn't want to run out of room. There's only a top, so we only set the top equal to 0, and we get x is equal to minus 8 divided by negative 6, 4/3. First derivative. What do we do next? Sign chart. What do we put in our sign chart? 4/3. Whose sign are we testing? What's the number on the left of 4/3?
0.
Uh-huh. Can I do this without writing it? Can we do this?
Yeah.
Who am I plugging them into?
8.
Right? So plug in 0. What's 8 minus 0?
8. Positive.
Positive. Right? What's a number after 4/3? Okay, plug in 2. What's 8 minus 6 times 2 is 12. 8 minus 12? Negative. What does that tell me about f? What is he doing on this interval? Increasing. What is he doing after? Decrease. And the first derivative test for relative extremis says, if I change from increasing to decreasing at a critical number that exists, no dot dot dot, what has to be it? If I want to be super spiffy, I would go ahead and take the 4/3 and go plug in the 4/3 to go find my y value to find the whole point, but whatever. We'll just stop there. Is that okay?
Yeah.
Okay. How does this compare and or contrast with the second derivative one?
Sign chart.
The second one won't have a sign chart. But where do we still start if we are doing, can I change colors just for sake of argument?
Yeah.
Okay, we'll do second derivative test. What's step number 1?
Domain.
Domain. Oh, that's silly. It's the same thing, right?
Yeah.
All real numbers. Step number 2.
First derivative. Critical numbers.
Oh, still do the first derivative? Oh, okay. Hold on, that stays the same. Nothing new here, right? So f prime of x is equal to 8 minus 6x, set it equal to 0, x is equal to 4/3. That's the same. Okay. Step number 3. No sign chart.
Second derivative.
Find the second derivative. So here's where we go new.
-6.
Second derivative, 0 minus 6 is just negative 6. Now some of you are like, huh? Hold on, what are we supposed to do with the second derivative? Plug it in, plug it in. Plug in what?
The critical number.
F double prime of 4/3. So this is going to confuse some of you. Is there an x to plug into?
No, it's -6.
But whatever. Negative 6 is a negative. The second derivative is negative. What does that tell me about f?
Relative mass.
F is concave down. I'm trying to connect it.
I'm sorry.
And so since it's concave down, if there's a critical number, what
We
kind of
have a
relative
mountain.
extreme?
And on top of the mountain.
You're going to have a mountain, on top of a mountain is a max. So therefore I can say relative max at question. Did they both come up with the same answer?
Yeah.
But different ways. But not that different. Step 1, same. Domain. Step 2, same. Critical numbers. Relative extrema has to happen in critical numbers. So the first derivative, pitchfork. Top and bottom equal to 0 if it has a bottom. So here's where it diverges. First derivative says, I want to know exactly how it's moving and changing. Second derivative says, hey, if he's easy to find, just plug into the second derivative, figure out the concavity, and say, what is it? What is it? But it only works, the second derivative test only works if there is concavity. So someone give me an example of a graph that the second derivative test would not work on.
Oh, so the a linear, the first equation.
Well, a linear won't have any relative extrema, so there wouldn't be any critical numbers, but that would fail earlier. You know what I mean? That would fail in the critical number step because there wouldn't be any.
Oh, discontinuities.
One that has a vertical asymptote, that's not going to work so well at the vertical asymptote. But what's one that has a relative extrema, but the second derivative test would fail? No, because it couldn't exist out there. For the second derivative test to work, it has to have concavity. What's the function that doesn't have any concavity?
I was
I just can't speak loud.
I just didn't hear it. But right, there's no concavity. There's no concave up or down, it's just lines. But is there a relative min?
Yes.
Oh, would we know that from the first derivative test? Yeah, decrease, increase, we'd be fine. We'd find it with the first derivative test, but would we find it with the second? No. So this does have some shortcomings, but if the second derivative is really easy, maybe some of you were like, oh yeah, that side had less work. Okay. What if, this is a really good one, but I'm not going to do it because time is running short, in the sense of we have more important things to talk about. So hold on, I like him, but let's save him until after everyone finishes their AP number 2. Wait, why am I saying that? Who is this a graph of? Ah. And F prime graphs get a little tricky. Okay, let's go back. Let's save him too. He's an application-y one. We can talk about him real quick. Let's talk about him real quick. He's faster than the other one. Who is this a graph of? F, right? Okay. What's F prime going to look like? Why is it a straight line?
Because
The derivative of a squared is going to be a single x, right? With a constant or something funny. But how do I know where to put him at all? When a function has a what? Has a min, a rounded min, what's the value of the derivative at that min?
Yeah.
The slope is 0. So where am I going to put a point for the derivative? It's going to be an x-intercept because it's a 0 of the derivative. And then I say, hey, what's my slope doing? Well, it's concave up, guys. What's my slope doing? My slope is increasing, right? So what's going to happen with my derivative? It's increasing. No big deal. I don't know exactly, but my slope's increasing because it's concave up. What's true about my second derivative? The derivative of a line is just a number, so it's going to be a straight line. And is it going to be a positive y value or a negative y value? Positive because what's the slope of the derivative? A positive. Or what's the concavity of f? Concave up, so therefore, I don't know exactly where, but I'm just going to draw a line and say whatever. It's a line that's up above the x-axis. Yeah.
How come, like F prime is a tangent line, but that's not what tangent to it?
Well, remember f prime, the graph of f prime, y equals all the different slopes at all the different points. So this slope is 0, this slope might be like 1, this slope might be like 2. So it goes and it hits the numbers of the slopes. This isn't actually graphing all the little baby tangent lines, because then we'd have to be finding all the little baby tangent lines with y minus y1 equals m times x minus x. Does that make sense? So this is just m. That's it. Okay. Now, this is one you guys are going to see in homework, and some of you that were working on 3-4, you might have gotten to it last night, so I thought I'd give you a couple hints and clues. 3-4 homework should be due tomorrow. Okay, it was due today, but I know there was a lot going on, some of you haven't had tons of time. It should be done tomorrow, and I might even spot check to make sure that you're doing all right and keeping up for tomorrow to give you some sort of accountability. But when you get to here, stink, what are we supposed to do? Question. I see relative extrema. What would we do for relative extrema given a function? What's step 1? Discontinuities, but he's a polynomial. Any discontinuities of a polynomial? Okay, step number 2. Find the derivative and set them equal to 0. All relative extrema have to come from 0 to the derivative. So, cool kids, even though there are these little like weird A, B, C, D things, they're constants. Please pretend they're numbers in front. How would we take the derivative?
3ax squared. 2bx.
Okay, and the derivative of d would be 0 because he's a constant. Set him equal to 0. Now hold on. We already know where some critical numbers are. Question, where are critical numbers?
3, 5, 4.
Not 4, why not? He's a pip. That's from the second derivative. Okay, so I can already say, you know what? I know that this thing has to equal 0 at 3. What am I doing? I'm plugging in 3 for x because I already know it works. And where else does it have to equal 0? At 5. How many unknowns do we have? Oh, how many equations do we have? System of equations, we need a third one. But wait, isn't there another clue? What's my other clue? If I find the second derivative, inflection points have to come from pips. Who is my second derivative? Well, let's go back to the first derivative. Derive again. And I know the second derivative must be 0 because a polynomial isn't going to be undefined. When x equals what?
4.
Really? So what does that mean? I have 3 equations and I have 3 unknowns. There must be a way to substitute in somewhere. Does this at least get you the idea? Okay. Relative maximums and minimums come from the first derivative. I'm trying to kind of reinforce that. Inflection points come from the second derivative. True? Now, hold on. If you guys have number 72 in homework, can we be strategic for a second? Number 71 is finished and solved and shown where? On CalcAB. You can kind of follow. But I've hopefully at least had us think through the idea of what's going on. Does that sound good? Okay. All right, let's keep going. I don't want to go over those. Let's go ahead and go straight to 3.5. Now listen here. We're going to 3.5. We're starting 3.5 because I have to get to 3.5 at least. Put the quiz tomorrow. All right, one more time. It's on sections. Look at the back. I changed it. 3.1, 3.3, and 3.4. It's not on 3.5. And it's not on Rolle's or mean value theorem 3.2. Okay? Literally, it's not going to be multiple choice. It's just going to be show me your work. You get partial credit for everything right you show me. Cool? I'm going to literally give you functions. Probably 2 different ones. Maybe 3 depending. No, probably just 2. What kinds of functions could they be? I don't know. Polynomials. Maybe like a fractional one where you do like a quotient rule. Maybe a square root one. Maybe trig. Probably not trig to be honest. Maybe an e to the or an ln. Haven't those all been ones you've been seeing in homework in 3.3 and 3.4? Okay. So you know the types that are available. And I can't give you a super crazy one like the example that I let you do a ... on yesterday and not even finish, right? And maybe I'll even just give you a derivative and say, hey, here you go. And you can skip some steps. Okay. I'm going to give you functions. And I'm going to say, analyze the following 4. Probably 2 different questions. Probably one of them will say, for increasing, decreasing relative extrema. What section is that? 3-3. And then another question probably will be analyze for concavity and points of inflection. What section is that? 3, 4. Probably a bonus on there. And I'm saying there will be 2 questions, 2 to 3. Okay? 2 to 3. Either way, are you going to have to be taking derivatives? Yes. Are you going to keep it as careful as you can? Yes. Are you stressing about matching? No. You're just doing the best you can all the way through. And if you make a mistake, that's okay. Keep going because you don't know, right? And you just give me an answer and then I'll be able to say, they made a mistake, but all this is right. I'll just take off a little bit. Sound good? You're going to have to find derivatives. Are you going to have to think about domain? Yeah, that's step number 1. So you have to think about domain, think about first derivatives and pitchforks for critical numbers for increasing, decreasing sign chart. You have to think about second derivatives, pitchfork, pips for sign chart. And you're going to have to think about those forevers as to how to know when or where there's a relative min or max, when or where there's a point of inflection. That's it. Does that sound better than maybe you were thinking? Why am I doing this? Some of you have fallen behind, and I just need to make sure that you can do what I need you to do before we go on. Does that sound good? Okay. And then what do you have over the weekend? 3 days to hopefully get some rest, hopefully get some relaxation, but hopefully get caught up in math so that we can finish this semester off well. Now listen, we've worked hard. We're going to work hard for another like 10-ish minutes, but we've worked hard. You're going to take a quiz tomorrow and get 3 days. Take a breath. Catch up. You're going to have a solid week where we're going to work hard, but then what do you get? Thanksgiving, where you can take a breath. I'm going to be in professional development Monday and Tuesday. You guys are going to have like all this free time-ish. Don't pack it full of useless things. Family is good. You need to spend some time on catching up so that we can finish the semester well. Okay? So we're going to work hard. We've worked hard this week. We're going to take a quiz tomorrow. We're going to work hard till tomorrow. Then we're going to get a little breath. Then we're going to work hard for a week. Then we're going to get a big breath. Then we're going to work really hard then the semester. Okay? Can we do this? Yeah.
For next week, do you have the calendar set up?
I have the calendar set up. We're a little bit behind on 3-5. But I don't think I technically have. I don't want to speak. Just look that up. Yeah, let's not distract ourselves right now. Okay, here we go. Lauren.
Can you start calculating tomorrow?
No. Why? If I ask you for increasing, decreasing relative mins, maxes, you could like kind of BS and then just give me something from a graph. That's not going to happen. But that means I can't give you anything too nasty as far as plugging in or like having a decimal and figuring out test values, etc. But might you have to be really careful in plugging in and like do a little bit of something on your scratch paper to make sure you have the right sign. But it can't be as nasty as some of those homework ones where it's like, what's the decimal so I even know what to plug in, you know what I mean? Alright, kiddo, section 3.5. Section 3.5. I really hoped that yesterday we could get into this and then tomorrow, or today, we could finish it up and then we'd have a quiz on something a little different tomorrow. But I want to show you what 3.5 is and show you how it's not really anything hugely new, everything new, whatever. Something or other's about new. And then my plan is tomorrow to take the quiz. If we have time, we'll come back in section 3.5, but at least you guys will see what's going on. This might be part of your catching up / getting ahead over this weekend. Here's what's going on. If I was to give you this graph, not this graph, this function, and say, no calculator, get me a graph. Why have we been working up to this? In pre-cal, what were different things we figured out that we could put on a graph, that we could solve for? X-intercepts, Y-intercepts, vertical asymptotes, poles, horizontal asymptotes, slanty asymptotes. Zeros, yeah, those are intercepts. Symmetries. But what have we added to that? Increasing, decreasing, mins, maxes, points of inflection. We have all we need. So what are we going to do to graph this puppy? We're going to start with pre-count. Then we're going to go to count. Now wait, pre-count. Come on. We got this. Pre-count. Pre-count. I say 14 identifies because if we can find 14 things that we can make on step number 15, we can make any graph. If we can do these 14 things, we can find any graph without a calculator. X-intercepts. Without calculus, or just with pre-calc. X-intercepts, what do? Set y equal to 0 and solve, right? Now, depending on the function, to be honest, that might be the hardest step. You're like, no way, we're in calculus. That's not, no, depending on the function, that might be the hardest step. Sometimes. But sometimes it's the easiest step. Y-intercept. He's usually the easiest, because what do you set equal to 0? X. You just plug in 0, and you're like, yay, we're going to solve for all of it. Remember, x-intercept is going to be some constant 0. Maybe you have more than one. Y-intercept, some constant with the y. Sorry, 0 and then some constant. Vertical asymptote. Non-removable. What does that mean? It doesn't factor out. Non-removable where the denominator equals 0. True? But the denominator equal to 0 and it doesn't factor out. Wholes. Removable. Where the denominator equals 0, but it does factor out. Horizontal asymptotes.
End behavior.
It's technically end behavior from pre-cal, but horizontal asymptotes, remember, when you're taking the limit as x goes to infinity or negative infinity of f of x and it equals an actual constant. And that's going to happen when degrees are tied. Oh, you have to have a top bottom? Mm-hmm. When degrees are tied or bottom wins. When degrees are tied, take the ratio of the leading coefficients. The bottom wins, horizontal asymptote is 0. Ugh. OA, who's that? Oblique asymptote, which means the slanty one. Oblique asymptote, when the top degree is 1 more than the bottom degree. When the top wins by only 1. So if you have like an x cubed over an x squared, when the top degree is 1 more than the bottom degree, how do you find an oblique asymptote? You take an f over g, and the top wins by 1. You put f in the box, and you do a long division. The oblique asymptote is y equals whatever mx plus b you get. When you forget if there is a remainder, you say, nah, I don't want you. If there is a remainder, you say no. Symmetry. I'm not going to go crazy with symmetry. If there's odd symmetry or even symmetry, odd symmetry, you plug in a negative x, the whole thing is negative. Even symmetry, you plug in a negative x and it gets absorbed, it cancels out when you simplify. In domain, well, you have to think about your domain problems that we already talked about. What are those domain problems we can get? Huh? You have to watch out for, as we already talked about, denominators. Watch out for denominators, because they can't equal 0. Watch out for square roots, because u has to be greater than or equal to 0. Watch out for logarithm, I'll just say ln, because u has to be greater than 0. And watch out for trig and piecewise. They have their own special deals as far as vertical asymptotes or separators where problems can occur. Now, is this all pre-cal? Technically, yes. We talked about limits to infinity for horizontal asymptotes, but you guys learned the degree test last year. And everything else, technically, pre-cal. Okay, how many does that get us? 1, 2, 3, 4, 5, 6, 7, 8. What are the other 6? Yeah.
What's for the OA, like the y is pointing to it? What's that supposed to be?
OA is a slanty asymptote. It's a slanted line asymptote. So when you do long division and you get a line up here, you would draw a dotted line at this line, and that would be what your graph would approach.
Yeah, but why is there like a y in it?
Oh, because you're going to get an mx plus b, and you graph the line y equals mx plus b.
Oh,
Does that make sense? Okay, those, you can go ahead and put your pencils down. So how do you get steps 9 through 14? You need your first derivative. So that'll get you here, here, and here, right? So this is what we're studying now. And then who else are you going to need for the other three? So what's the quiz on tomorrow? Let's make sure we can do this before we put it in context of a bigger find a nasty graph problem. Sound good? Kiddos, you don't necessarily have to have your spiral entirely done by tomorrow, but if you have not practiced any of 3-3 or 3-4, the probability of you doing well goes way down. Please practice. I'll be here during lunch after school. I might even have some practice problems just on the boards if you guys want to tackle them. I'm gonna get ready. I'll see you guys later.
rap, like you're in a rap. And there's that we have to rap. I said rip. Volunteer.
There's so much fun in here.
Try to see if there's some way you come in just for like half an hour for us to do it.
No, it's not going on. No, you even said I'm just giving the stamp sheet. I lost mine. I don't. Yeah, it's so long. I know it's missing 3 or 4.
And like you're for sure that it's gone, like it's
Yeah.
highlighted.
Oh, red.
I just at some point today, I think put a few on there.
We didn't
Put
lose
them all in. I'll get you a few.
Freshman? Junior? Sophomore?